move on to control flow in CSC323. And so what is control flow exactly? Well, if all we could do was write programs which manipulated expressions and data structures and maybe provided some output, we would have some computational capability. But I think when programs really get into their own, and I think when things get really complicated for the freshmen because they have much more interesting problems to solve, is when we open up the gates to control flow. So control flow is really two basic ideas, which we're going to explore in various languages. One is selecting different execution paths, and the other is the ability to repeat statement execution. So when you add those two capabilities on top of what we've discussed so far, you have a lot of power in the programs that you write. And different languages approach control flow in different ways. And there's different problems with different approaches. So we're going to explore some of those. As a warm-up, what I thought would be interesting to do is to have you take a look at a piece of Fortran code and try to answer this question. If we assume that I has the value of 3, I starts with the value of 3, what are we going to see as output from this Fortran program? Now, if you look at this Fortran program, it is very similar to SPIM, which you're familiar with from Shai's computer architecture class. So it does look very assembly language-like, but it's actually a somewhat high-level language. All right, so I wanted you to hit the pause button and fill in this chart. What is the value of I? What is the value of j? What is the output until the program hits statement 99, which means continue, and it will continue executing the rest of the code beyond this little program snippet. All right, go for it. Okay, so let's take a look at what happens when this program executes. So first of all, we enter the program at the line that says go to 10. And second, we actually go to statement 10. So we jump over some code and we end up here at statement 10, which says print star line 10. So we're going to print out line 10. All right, at this moment in time, the value of I is 3. Okay, so the next thing that happens is we execute this line immediately below it that says j equals 2. So j is equal to 2. Now, the line below that, line 69, says j equals j minus 1. So now j is the value of 1. And there's some dots here. So there's some code, some interesting code that's going to get executed. And at the end of that interesting code getting executed, we have an if statement that says, if j is not equal to 0, then go to line 69. So we're going to go from this if statement, because j currently has the value of 1, we're going to go from this if statement up to that line 69. And j is going to be equal to j minus 1, so j is going to be equal to 0 now. We're going to execute this code again, and then we'll hit that if statement that says, if j is not equal to 0, go to 69. Well, j is equal to 0, and so we're going to go to 23. So we go to 23, that's a continue statement, which basically means keep executing the code after this. And this statement says, right after the continue statement, we have a line that says I is equal to I minus 1. All right, so I is 3, now it's 2. And the next statement says if I is equal to 0, go to 99. Well, it's not equal to 0 yet, it's 2. So we're going to print line 10 again as the next statement, line 10. All right, j gets reset to 2, and then j gets decremented by 1. We execute a block of code inside that dots. We check to see if j is not equal to 0, which it isn't. So we're going to go to 69. Then j is going to be equal to j minus 1, so j is going to be equal to 0. we're going to execute that block of code again. And then is j not equal to 0? No, actually j is equal to 0. So we're back to this go to 23 statement again. And so I is going to be set equal to 1. And then we're basically going to repeat this process again. So I is 1. We're going to print line 10 again. J is going to be set equal to 2, then 1, then 0. And now that j is 0, we're going to execute this code here. If j is not equal to 0, go to 69. Well, it is equal to 0. So we're going to go to 23. We're at 23. It says continue. I is equal to I minus 1. So I is going to be 0. If I is equal to 0, go to 99. So now we're going to go to 99, and we're done with this chunk of code. Now, if you think that was kind of convoluted, this is not convoluted at all if you lived in the world of Fortran 77. This would be a pretty standard kind of piece of code to write, but you can imagine that, you know, from a modern programming language standpoint, it is pretty bug-ridden. It has the potential for bugs. And you can see easily how with just one counter set up wrong, you could get into a lot of trouble. Here's what I'd like you to do, though. Take a moment, after thinking about what this code does, why don't you take a moment and see if you can rewrite this code using a modern repetition mechanism. All right? So, for example, if you wanted to convert this to Java or to C++, what would this code look like? All right? So, hit the pause button, think about this, and give it a shot. All right, so what could this code convert to? Well, actually, this code is a pretty simple for loop that goes like this. For int I equals 3, I is greater than 0, I minus minus, and system out print line 10, for j equals 1, j is greater than or equal to 0, j minus minus, and the meat of the code that you want to execute would be in there. Okay, so it's basically a nested for loop. So a lot of complicated code to make a nested for loop work. Okay, so let's talk about that was just like an example to show you what one type of control flow statement looks like in a language like Fortran 77. Let's take a look at the two broad topics we want to attack today. So the first one is selection statements. So selection statements have basically two flavors. There is the two-way or the n-way selection statement. And the goal of selection statements is to allow you to choose between two or more paths in the program. Okay, so let's take a look at the two-way selection statement to start out with and just kind of pick it apart. Because whenever you encounter a new language, the language is going to have some kind of two-way or n-way or both selection statement. And you need to think about the different parts that make up a selection statement. So one of the things that you have to worry about is the control expression. So the control expression is usually evaluates to a Boolean value. But not always, and we'll take a look at an example where that's not true. And it often needs parentheses, but not always. Okay. So let's take a look at an example here. First of all, we'll attack the needs parens example. So take a look at this piece of code. If x is greater than 10, cout x is big. And all right. So if we did not have parens here, what is the expression that needs to be evaluated? And then what is the code that's going to get executed if we look at this example? Is it possible for the language to figure this out without parens? And I think the answer here is it could get a little weird. This code right here, in theory, maybe this returns a value. Maybe that value could somehow be used in combination with this 10 to do something. Maybe this could be an operator. That takes 1 or 2 arguments. I guess where I'm heading here is it's hard to tell when the Boolean expression ends and when the statement that you want to execute, if the Boolean expression is true, begins. And so most modern languages force you to put a paren around the full Boolean expression that you want evaluated before the statement gets executed. There are exceptions to this. If there's an explicit then statement, then you don't need to put parens around the Boolean expression. So here is an example. In Ada, so this is C++. In Ada, you would do this. If x is greater than 10, then print x is big. All right, this then makes it very clear that where the Boolean expression ends and where the statement begins. All right, so that's part one of control expressions. Part two is this idea of evaluating to a Boolean, that the controlling expression that makes the decision whether that statement gets executed or not evaluates a Boolean. So that's true in most languages, but there is some quirkiness, and depending on the language that you're working with. So for example, in C++, you can do this. If -1 cout true, else cout false. Let me do a parallel one to this. Just going to do it real quick. Harder for you to do this, I bet, except for menu. You can do this, no problem. Whoops. Let me just shrink this down a little bit. Oh, that did not go well. Okay, let's shrink this. Okay. What do you think that this will work? All right, so here's option 1 here, if -1, and here's option 2, if 0. So will true or false get printed out for the first expression? So that's the question. Will we output true or will we output false? So the answer to the first one is we're going to output true. The way that C++ works is anything that is non-zero, any value that is non-zero will get interpreted as true when you put it in a Boolean expression. So -1, even though it's kind of a negative number, it's not considered false, it's considered true. The second expression, if 0, see out true or false, what do you think that's going to output? Well, the answer to that is it's going to output false, because in C++, anything that is non-zero is considered true, anything that is 0 is considered false. Right? Great.